Hello everyone. The problem that we are gonna be solving today is lexicographically smallest permutation greater than the target. So let us read this problem. This problem was asked in the weekly contest 472, and this is a medium kind of problem where you have to think a lot more than do. Like you also have to code it up. The coding part is also a little bit tricky, but it is not that tricky if you understand what you have to do. So let us read the problem. You are given two strings s and target, both having the same length, consisting of lowercase English letters. What have they given? We have lowercase English letters inside both of these strings, and both have the same length. Okay. Now we need to return the lexicographically smallest permutation of s. We need to return some permutation of s. What is a permutation? They've given a permutation is a rearrangement of all characters. Okay, we need to rearrange the letters of s such that it is strictly greater than target. Strictly greater than target. If no permutation of s is lexicographically strictly greater than target, return an empty string. Okay, what is lexicographically strictly greater? So a string A is lexicographically strictly greater than string B of the same length if the first position where A and B differ, string A has a letter that appears later in the alphabet than the corresponding letter B. Okay, you don't understand it in the very first go, so let me break it down in a easier way. So they have given this example. Where the string is ABC and T is BBA. String S is ABC and T is BBA. So basically we need to use the letters, the characters that are available in this, to create a string that is lexicographically greater than this. Okay, so what is lexicographically greater? So now we need something greater than this. So now lexicographically greater means that it appears later than the given alphabet. So now B is lexicographically greater than A. Why? Because A, B, C, D, E, F, G, all of these come in line, right? All of these come in line. And if you all know about a little bit about ASCII values, the ASCII value of this is 97, this is 98, this is 99, 98, 98, 97. Okay, so if you all know a little bit about ASCII values, the ASCII value of B is greater than that of A, and hence B is greater than A lexicographically. That is what lexicographically greater means, right? B is greater than A, C is greater than A, C is greater than B, D is greater than E. No, this is wrong. F is greater than E. Yes, because E, F, G, right? So I think you all understood what lexicographical means, lexicographically greater means. So now we need to use this. So how do we start? So in order to, what have they asked us? They have asked us smallest permutation greater than target. So we need the smallest permutation of this that is greater than target, right? So we need to be as close as target, but greater than it. We need to be as close as target but greater than it. Okay, so how do we be as close as target? How? Basically, how do we be as close as target? We try to copy it. By copying the given string, we can be as close as it. Okay, so let's start. So we have a B here. We are trying to copy the string using the letters inside of this. We have a B here, we have a B here, we write a b, we build a b. Okay, we write a b now. Okay, so this was done, this was done. We have one more b here, we have one more b here, but we are exhausted of b. We do not have a b anymore, we do not have a b anymore. So what do we do? What do we do? What do we do? Since we need to be as close as this but greater than it, since we cannot copy it anymore, we cannot clone this string, we cannot copy this string anymore, because we have been exhausted. We do not have this item inside of our pool in order to clone this, right? So now we move on. We first try to be as close. Our first step is to be as close as possible. After that, we want to be great, we want to be greater, right? We want to be greater. So a b is done, a b is done. Now we are here. Now in order to be greater, in order to be greater, we need to go a little above, we need to go a little above, right? We need to find something greater than, we need to find something greater than b. What is greater than b? C. So we add a c, we add a c, and then since now this is greater, now if you see, if you make any permutation now after this, it will be the smallest permutation which is greater than this, right? So let's say there were 1,000 permutations greater than this would be the smallest, because b here, it is a difference of just one letter, right? So I hope you all understood this concept. I hope you all understood this concept. Now we just clone it, the remaining characters. Okay, so it's okay if you all did not understand, we'll go through the steps on how to do that. Okay, so we have 6 steps that we need to do, right? First, we need to create a frequency array. We need to create a frequency array. Why? Because we have to know na, what all characters do we have to use. So we need to know that we have 1a, we have 1b, and we have 1c. We need to know. So we create our frequency array, which we can call it as pool. Which we can call it as pool. This is our pool. Okay. So we can call this as pool from the s, string s. Okay. Now second is we need to find a breakpoint. We need to find a breakpoint. Okay, breakpoint. What is a breakpoint? A breakpoint means the first character where greater character is used. The first character where greater character is used, all characters before that are copied from the string as it is. So basically a breakpoint is the character which makes our string lexicographically greater but smallest. So before the breakpoint, basically this is our C is our breakpoint. C is our breakpoint. Why? Because C is where we stopped copying the string. We stopped being as close as string. We stopped being close by copying it. We stopped copying and we put a greater value. So wherever we put a greater value, that is our breakpoint. So we select a breakpoint. Then we copy all the characters till breakpoint in answer. Okay, so basically it's telling us to be as close as by copying it, and how do we do that? We do that by copying. If this is our breakpoint, we copy whatever was here, we copy whatever came before it. If this, so basically this was my breakpoint, right? So whatever was there before it, we copy. Okay, now next, find the smallest character which is lexicographically greater than character at breakpoint and add it to the answer. Find the smallest character which is lexicographically greater than character at breakpoint and add it to the answer. Basically till now This was built because we copied in order to be as close as now we found this as our breakpoint. Okay, we found this as our breakpoint. Now we found this as our breakpoint. Okay, so now what is it saying? We need to find the smallest character which is lexicographically greater. So assume that here one D would also be there. Just assume that if a D was also here, right? So this is also lexicographically greater than our breakpoint, right? But we do not select this because this is the smallest one. What does our question say? Our question says smallest permutation. So we select this. Okay, I hope you all understood that. We select this. Okay, we select the character at breakpoint and add the smallest character which is greater. Let me just underline that. It is a very important point. We need a smallest character which is lexicographically greater than the character at breakpoint. Okay, we did that. And after that, fill the remaining in ascending order. Now let's just say again, if we had a D here, then we would fill A and then D and not D and then A. So B, C, A, D and B, C, D, A. Both of these are lexicographically greater than this. Do you agree? Both of these are lexicographically greater than this. Basically, this is smaller than both of this lexicographically, and that is what we want, right? But the question has asked smallest permutation greater than target. So in order to keep the permutation smallest, at breakpoint we selected the greater one. That means anything that we're building now will be greater than the given one. We select that, we did that at breakpoint. So now we want to keep it small. We want to keep it smallest, and hence we add it in ascending order. We add it in the order A is less than B is less than C. So if A was there, we added A. If an hypothetical letter alpha is lexicographically less than that, oh, just forget it. If there was a D here, so we chose this instead of this. Why? Because A is lexicographically smaller than D, and we need to keep the string lexicographically smallest, right? And hence we chose that. So these were our list of steps that we need to follow. B, C, A. And the final is check if the made up string with prev answer, if new answer is old answer, update the new answer. That is fair enough. We'll get to know when we write the code, because you must have thought ki how are we selecting this as the breakpoint? How will we know? So I could not really think of an answer to this question. We do not know. How do we select this as a breakpoint? I don't know. So what do? We first select this as the breakpoint, calculate our lexicographically greater string if possible. We select this as a breakpoint, calculate the lexicographical string if possible. We select this as a breakpoint, calculate the lexicographical string if it is possible. And then at the last, if let's say I use this as the breakpoint and calculate a string, and I get a string x, and if I use this as a breakpoint and I get a string y, if y is lexicographically smaller than x, I will use the string here. I will update that string here as the answer. I hope you all understood the steps. I hope you all understood the concept. So basically, I have divided this here. B is the breakpoint, prefix is all the copied strings, copied characters, and these are increasing ordered, increasing, remaining, and this is nothing but our breakpoint. So I hope you all understood why are we copying it here. We are trying to keep it as close as T by copying it, and whenever we can't keep it same anymore, we find the greater one. So prefix is the characters before breakpoint which are copied as it is from the target. Suffix are the remaining characters after breakpoint which are added from the remaining pool of characters in increasing order. Okay, that was all about the theory of this question. It is not a lot. It is a lot to think, obviously, but once you all have solved this kind of problem somewhere sometime, like if you all see this video and practice it 2-3 days later once again on your own, I think this is a simple problem. The intuition behind it is quite straightforward, and the coding part is a little tricky. The more practice we do, the more we will get better at coding. I myself, if I'm being honest, was not able to code this up. I was able to think all of this, but I was not able to code this up during the contest. So that is a very sad part. So anyways, we're learning all together. Now we can code this up together as well, and we will. And there you go. We will take another example here. Now, if you all noticed, I said a sentence. We will try each element in target as breakpoint and calculate the answer. Calculate the answer if possible. I said the words if possible. If possible. These are very important words that will be a major part in our coding. This will play a major role in our coding. I personally missed this part when I was coding it up. This is a very, very important part. Note. Anyways, no need to do all of that. I'll just do this. Yeah. IMP. Yeah, anyways, so let's just take an example. Of leet and code. We need to create a lexicographical string of leet, which is greater lexicographically than code, LeetCode. So what do? First we create a pool of characters. And there you go, we created a pool of characters in increasing order. Obviously, what we can do is we can just create an array. Of length 26 and use ASCII values to fill here. So basically 0 minus a, right? 0 minus a will just a minus a will just get me at 0. So character minus a will give me the position of it at 0. We'll code it up, we'll see. So basically we'll just have this pool of characters in increasing order by default when we use the frequency array of characters. And there you go, we use C as a breakpoint first. Okay, what was our step 1? Create a pool 1. What was our step 2? Select breakpoint. We selected breakpoint. Step 3, smallest character which is lexicographically greater at breakpoint and add to the answer. Okay, no, step 3 was copy all the characters till breakpoint. That means till before breakpoint. Since I do not have anything before breakpoint, I will just skip that part. I will go to step 4. Step 4 is find the smallest character which is lexicographically greater than character at breakpoint. Okay, I have C. I need to find the smallest character which is lexicographically greater than C, which is E, obviously. So I put E here. Okay, now I got the character at breakpoint. So I got the character at breakpoint, and our pool changed to 1, right? Because we used this up. Now we fill this up in ascending order, EELT. Okay, so what is our answer? Our answer, by considering C as the breakpoint, is EELT. Okay, now what do we do next? What do we do next? What do we do next? We move our breakpoint to O. Okay, we move our breakpoint to O. Now what do? We copy the string as it is. We copy the string as it is. Now we check in our pool. We need to have this character here also, right? But C is not in our pool, so we just continue. We do not do anything with that. So we take D as our breakpoint. Again, we do not have it in our pool, so we continue. This is what I meant when I said if possible. There are many cases where things won't be possible, because basically we are restricted to these. We do not have an infinite supply of characters, right? We're restricted to these characters, so we cannot copy C and O here. Because we do not have it in the pool, right? We do not have C in the pool, so we can't copy it down. So again we move ahead. Oh, what just happened? Again we move ahead. We take E as our breakpoint. We try to copy C. We do not have C. We end. This moves out of bounds. Hence both our loops which we are going to be coding up will do. And our answer was this. So we return this. Now let's just take one more example. That they have only given. That is Baba and S is equal to Baba and T is equal to BBAA. Okay. So now again initially our answer will be null. Answer will be just nothing, right? Our answer will be nothing. Then we create our step 1 was to create a pool in increasing order. This is our pool in increasing order. Okay, okay. Now what do? We select a breakpoint. Okay, what is step number 3? We copy all the elements before breakpoint. Is there anything before breakpoint? No. So we go here. Now what do we do here? We find the greatest element, that is, we find the smallest element greater than this. Find the smallest element greater than B. Is there any element greater than B? No. That means we cannot create a lexicographically greater string. So we move ahead. Again, emphasis on if possible. Break. Again, the same thing. Okay. Now here B. First, what step 1 was? Copy the prefix. Copy the prefix. Copy. B. Find a lexicographically greater string than B. Greater character than B. We do not have it here. So again, go back to normal. Now, okay, what just happened? Yeah, we go ahead. A. Now we copy the string previous. We copy the prefix. What is the prefix? Prefix is this. Read it later. I will provide the notes. So we copy this. Now we copy this. This becomes 0. Now we find a string that is lexicographically smallest character that is lexicographically greater than this. We find something that is greater than this. Is there? No. Again, move ahead. No. Again, the same thing. We will copy this down. BBA. Again, we have to find something that is lexicographically greater than this. Do we have it? No. Then this goes out of bounds. We are done with our coding, and our answer we return as an empty string. So what had they said? They had said that return an empty string if no permutation lexicographically strictly greater than target is found. So that is exactly what we're doing here as well. So this is our theory behind of this. This is the intuition, this is the thought process, this is the coding. This is not the coding, this is the thought process, this is the logic behind our problem, and we will now quickly code it up. Let's just quickly code this up. Okay, so just a second, let me move my tablet in the side, and yeah, my tablet is alive. So first we need our int n, that is target.length, can be anything, s.length because both n is same. Now int pool, we create a pool is equal to new int n. No, n, is it n? No, 26. Store the frequency of all characters, right? We create our pool. Now this is our step 1 for int for char c in s dot 2 char array c in 2 char array pool at c minus a plus plus c minus a plus plus. Okay, what does this essentially do? This converts things into ASCII, right? So let's say c is equal to b. Okay, so the ASCII for b is 98, I just told you all. So what it does, it does 98 minus ASCII of a, that is 97, and it gives me 1. So it stores this in the particular index, right? So ASCII indexing. Okay, now basically this gives us our pool. Now we create our answer is equal to null. Now step 2, select breakpoint. Step 1 was pool create. Select breakpoint for int I is equal to 0, I is less than n, I plus plus, I is our, let's just keep this as b for simplicity. Okay, so let's just keep it as b for simplicity. Int array temp pool is equal to pool.clone. Why are we cloning this? Because every time I change my breakpoint, I am going to need the pool again and again, right? So we keep this as an original and we keep this here, or better yet, let's just keep this as p. Let's just name this as pool and let's just keep it as p, just for simplicity. Okay, now we have our string builder SB. In order to create an answer, new string builder is equal to new string builder, that's it. And now we move on with our step 3, that is match prefix clone prefix as is. So for int I is equal to 0, I is less than breakpoint I plus plus, we select our character ch is equal to target dot char at I, right? So what did we do? We selected the given character till breakpoint, right? We're iterating through that. So if I am to show you an example here, what are we doing in that part? If I am to show using this example, let's say this is my breakpoint. So I am iterating from this to this. Let's say I had a D here and this was my breakpoint. I am iterating from this. This is my B, right? So I am iterating to 0 and 1, 0 and 1. I am iterating here. Okay. So I am iterating here. I am picking up the character, and if if in my pool ch minus a is greater than 0, basically if this exists and is greater than 0, that means if the character is existing inside of the pool, I append ch and pool ch minus a minus minus, because I am using it up, right? And if it does not exist, that means our smallest lexicographically greater permutation is not possible, and hence we break. And in order to break the upper loop as well, not break the upper loop, basically to go to the next breakpoint, we need a flag. Int valid. Let's just say boolean valid. Boolean is much easier to understand. Boolean valid flag. We create a valid flag as false. No. Let's just assume it to be true. And if it is not valid, if this happens, then it is not valid. We break it off. And if we are not valid, or basically if valid equal false, continue. That means move on. If I cannot clone the prefix due to lack of chars in pool, go to the next breakpoint and try again. Okay, this we're doing this. Now let's say that we cloned the prefix. Now we are at the breakpoint, right? Now we cloned the prefix. Now we are at the breakpoint. We need to find the smallest char which is greater than the char at breakpoint. Okay, how do we do that? So char, let's say target character is t, which is nothing but target dot char at breakpoint. Target dot char at b is nothing but target dot char at b, and from here starts our step 4. What was our step 4? Our step 4 was smallest character. We have just written it above. So from here starts our step 4. What do we do now? Somebody tell me, comment down below. What do we do now? We iterate inside the target array, inside the pool. We iterate inside the pool, starting from the character at breakpoint's text character. Let's say my breakpoint character is b. Then inside the pool I search from c. Okay, I search from c. So how do we do that? Int j is equal to 0. J is less than 26. Oh no, what am I even doing? No, we are not doing that. For int j is equal to target char minus a plus 1. J is less than 26. J plus j was not equal to 0. So basically this gives me the ASCII, and this goes to the next character. If my ASCII, my target character was b, this gave me the ASCII for b 98. This made me go to c 99. Okay, so now we are iterating. If my pool at j is greater than 0, sb dot append character of a plus j. What is this doing? This is giving me 97 plus the character which I need. That, let's say if it was c, then c was at index 2, so 97 plus 2 gives me 99. The character of 99 is nothing but c, so c gets appended inside of this, and then pool at j minus minus, and we break. Now comes the case if possible. I told you to emphasize a lot on if possible. So what do? Here we created this, right? So what if I just did not find a greater character? Boolean found is equal to false. And here found is equal to true. Since I found it. So if found equal to true, I will continue. Oh no, if not found, if I do not find any character which is lexicographically greater than the character at breakpoint, oh my god, this is getting so confusing, but once you code it up on your own, you will understand what is happening. So if this happens, so there you go, I continue, I go to the next breakpoint, go to the next breakpoint if greater char is not found, or let's just write it 404. If you get it, you get it. So now we move on to our step number 5, right? What was step number 5? Fill suffix in increasing order. It's very simple. Int I is equal to 0, I is less than 26, I plus plus, while pool at I is greater than 0, sb dot append character of a plus I, and pool at I minus minus, and that's it. What will this do? This will pick the smallest one first and then keep on appending it till it is exhausted from the pool, and then finally step 6, we update our answer. String temp is equal to sb.toString. We create the string finally, and then if my result equal to null, let's say my result is null, that means a previous result has not been created, or temp.compare to result. Let's say I have a result that was previously existing, or if I do not have, then temp.result is less than 0. That means the new result is lexicographically smaller than the previous result. Then I update the result to temp. And that's it. I think I'm missing some bracket somewhere. I think the compiler will tell me what all issues I've made and what all issues I've not made. So I'll just return result. Okay, I cannot return the result directly, because if result is equal to null, then I will return empty string. Otherwise I will return result. I hope this works. And okay, cannot find the symbol s, cannot find the symbol pool. Int n is equal to s dot length. Okay, this cannot find the variable pool. Int pool is p dot clone. Why can you not find pool? Okay, sorry, p. Okay, This should work now. Okay, cannot find a symbol result. Cannot find a symbol result. Why? Oh, my bad. We're using answer. We're using answer. So, cannot find result again. Oh god. Result, no. Answer. Answer. Small issues, these always occur, but in LeetCode it is fine. In CP, these cost you a lot on Code Forces, Code Chef, wherever. There you go, our answer was accepted, and I hope you all enjoyed. Thank you so much.